Good day, this is Mr. Max. So today I am working on paper 1 that was written in November of 2024. This is mathematics paper 1 for ordinary level. And I've highlighted some things that you always need to check before you just start off by delving into the paper. So your additional materials that you're going to require are the things that are allowable in the exam. Obviously, you will need geometrical instruments, so which means there will be most probably a question that deals with construction. Then obviously you're allowed to use a non-programmable calculator, the scientific one. And then there are a few instructions and information that you need to take note of. Of course, I've highlighted one here in blue, so all the questions must be answered. In fact, there are 34 questions in this paper. And then if the degree of accuracy is not specified in the question, and if the answer is in fact not exact, then you need to give your answer to 3 significant figures. And when you're dealing with angles, you give them to 1 decimal place, and this is now the angles in degrees. And then for pi, you're either advised to use your calculator value or to use 3.142. All right, now that you acquaint yourself with that, I think we can just dive into this. Now, it is also advisable that you have your calculator ready with you. Of course, this type 1 is not allowed in the exam because they have got some programmable features, but there's also an obvious reason that I'm using this to show you quite a few things that you can do as you are being prepared for life. Now, the first question is asking you simply to work out what this gives you. Now, there is no need to beat around the bush. If you have a problem, you can just straight up put the stuff in the calculator and it gives you the correct answer. Okay, and then you just have to make sure that you apply the principles of BODMAS. Then you have to divide, and then you multiply, or you multiply, divide, and then you get the sum of that. So in a nutshell then, because this is a question that looks quite straightforward, but it's a 1-mark question, so don't waste too much time on stuff like this. 15 divided by 3, of course, that is 5, and 2 times 7, that is 14. So we expect the answer here of 19, okay? And often you will find very different answers. So it's a calculator-based paper, so just go ahead and punch it in and just get the correct answer without you having a problem. Okay, and this one here we obviously have to do our ordering and our comparing. So to make the following statements true, I always like to write this in decimal form. So of course this one means negative 0.333, and that 3 keeps on recurring. This one here means negative 0.5. Okay, now if you were now to look and see which one is bigger than or smaller than, or are they equal to, in fact, think of this as a number on a number line, so to speak. So what you'll be having, if we have let's say 0 over here, and let's say we have negative 1 over here, and let's suppose I say, in fact, let's not bring negative 1 so close. Okay, so let's say negative 1 is all the way somewhere here, and this will be halfway, so this will be negative 0.5. So the closer the number is to 0, or as the number is going to the right side, the bigger the number is. Now, if you have to think, where would negative 0.333 recurring lie? Well, it's going to be much more closer to 0. Okay, so it will probably be a value that is somewhere here. So this is where we can find negative 0.33 and so on and so on. So since it's closer to 0, it's towards the right of where negative 0.5 is, that implies that this number is bigger. Now when you look at part B, again, grab your calculator and just find out what is pi times pi, or you take pi and you square it. Okay, and then you see what it is. Okay, so of course this is a number that goes on and on and on. Now I'm going to go until maybe say about 4 decimal places, just to do my comparison. So this is about 9.8696 and so on, and of course this one is already 9.87. Now what you do look at is you look at place values. So there's nothing that the units can tell you because in fact the same with the tens. Can you see that they're the same? But now you come to the hundreds, and this has got 600s as opposed to this one having 700s. Now because of that fact, it definitely makes this number smaller. It doesn't really now matter what is after that. It's as you go along with your place value. All right, you have got a decimal here, and you are supposed to give it correct to the first instance to 3 decimal places. So the takeaway here is you must have 3 digits after the decimal point. Okay, so the reason why this becomes a 5 is obviously because of that 7 over there. So there must be 3 decimal places in your answer. When it says give your answer to 3 significant figures, now take note, what is significant figure? Well, it's the first non-zero digit in the number. Like this 5 here will be the first significant figure, and this 4 will be the second significant figure. But you do not throw away the zeros there. So you still have 0.0, but your significant figures, they start from the most significant value, which is this 500s here. So that's the first, the second, and the third. So of course that 3 cannot change that 7, so you're just going to go ahead and write 0.0547. Of course, when you are giving this number in standard form, there's so many things you can do. Of course, you can also use your calculator, but there's absolutely no need for that. For a number to be in standard form, it would be a times 10, base 10 raised to the power of n, where the n is nothing but the, let's suppose we say the n is nothing but an integer. Okay, so it has to be a whole number, positive or negative, or 0 for that matter. And the a is a number that is less than 10, greater than or equal to 1. So it therefore implies that the first digit here will be, I can go ahead and write it as 5.47. Now I'm not going to continue the other values, times 10. Now of course this number is small, so if I now have to bring the comma closer by here, effectively this number, I'm making it bigger, so this is going to be a negative here. All right, and I've moved it twice. Okay, this can't be a big value, can't be positive, then obviously the number will become much bigger. Okay, so you make the number smaller, so bigger, so you have to make the power smaller. Anyway, these are straightforward workings that you should be able to master. Okay, so we can take a small break, and we'll continue. All right, so we will continue, and we are going to start with question 4. A mathematics teacher bought 15 calculators. Okay, so that is 15 calculators, and he bought them for $145 each. I'm not going to put the units there. And then also a number of different calculators, and these calculators, they cost 76 Namibian dollars, and of course we don't know how many calculators they are, and the total of them is 2,783. Okay, so go ahead, I created a little equation there where there are many ways you can find this answer. All right, and you can just go ahead and punch in and work your magic, as it was, for you to calculate the missing number or that missing x. So I'm just gonna solve this equation. So I've got 76x over here, and that's 2783. Take away, because that's a positive value over there, 2,175. Of course, this is going to leave you with 76x is equal to 608, and of course the number of calculators would be if you were to continue, it would be that x would be 608. You divide that by 76. Of course, that gives you nothing but 8 calculators. Now, there are different ways. There are wrong ways to calculate this, but this ideally will be the correct approach. So I suggest that you stick to creating some sort of equation or finding that 608, that would imply so much, and then you work your way from there. Okay, then they are asking you to convert this decimal to a common fraction. Again, there's no need. This is not going to give you a mark over here because it says give your answer to in its simplest form. So you can just press 0.42 or 0.42 on the calculator and you get it. For you, half of 42 is 21, half of 100 is 50, and that would be in its simplest form. So it's 21 over 50. So again, these are not marks that you should be losing, okay? Since you're warming up. Another one, this one is also something that you can also calculate using a calculator. Of course, I know that 16 is nothing but 2 raised to the power of 4, and this is now obviously if I was to write 16 as a product with prime factors, and once you have stuff like this, I know that the rule is that you are multiplying the indices there, and if you multiply the indices, well, you're going to get your final answer. But again, I said, if your knowledge of indices is not as advanced, you can just simply go ahead and use your calculator. So you had 16, it should be raised to a quarter or 1/4, and then it gives you the answer. And then you move from there. It's 1 mark. There is no method that is required there. Right, once you come to question 7, again, you have a list of numbers, and these 4 numbers, they want you first of all to write down the largest number. So the largest number, again, this will prompt you to go ahead and perhaps maybe write them as decimals, like this 4 over 9 as a decimal will be 0.444 recurring. This 33 over 79 would be nothing but 0.41772. Of course, you can go ahead and check with your calculator. And this 44.5% is nothing but 0.445. Now again, you compare place values. So the first 4 does not really change, doesn't give you any direction. But here you have your hundreds, it's 500s, 400s, 100s, 400s. So this one, 0.45, becomes the bigger one there because of that position of that place value of the 5. Now, a number close to 1 over root 5, of course, you can go ahead and punch that onto your calculator. It should give you 0.447213, and so on and so on. Now, of course, if you do the comparison, 0.447, you have got 0.444, then this is the 5 here. So, of course, 44.5% will be closer, because if you look at 44.5%, it's 0.445. So, this one is just bigger by 2 or 1,000ths of a number or a value there. So basically, it's very close to that one. Okay, so that would be your answer there. Right, then question 8 says a journey to school takes 39 minutes. Calculate the latest time she can leave home if she must be at school at 7:15. Of course, I can use the built-in time function, so I know that 7, I'm using this, 15, punching that in. Again, I'm going to subtract 39 minutes from it, so I'm going to have 0 hours and 39 minutes. Well, of course, what does that give me? It gives me 6:36, so it means the person has to go at 06:36. That's obviously the time in the morning where the person have to leave. Okay, you can obviously do different type of calculations over there. You can do your subtraction if you want to. So some people will say, okay, wait a minute, I have got that time, which I'm going to change, borrowing an hour, that gives me 06, and taking that 60, that hour to 15, an hour is 60 minutes, so that's going to make that 75. I hope you know where it comes from. That is the 15 plus the 60. And then I have here 39 minutes. The reason why I could not punch 39 minutes over there, I can't be subtracting 39 minutes from 15 minutes. Okay, so essentially, if you now have to do your subtraction, and I hope you don't have a problem with that, you can just simply say, okay, 75 take away 39. Of course, that is going to give you 36. So that gives you the 36 minutes. And of course, your hour or your time is 6. So that's also one way to go about that. All right, part B. Nothing to be afraid of. You have got 3 hours and 35 or 3.35 hours. This is the decimal version, but the 3 there means it's 3 hours over here. Now, the 0.35 part, you're going to change it into minutes by multiplying it by 60, since you have got 60 minutes in an hour. And if you were to punch that in, you have to go and say, okay, wait a minute, that's 0.35 multiplied by 60. That means 21 minutes, okay? And your work there is done. Okay, let's get to question number 9. The diagram shows 3 sets A, B, and C, and you are supposed to shade on the Venn diagram the region B intersects C. Of course, so this is basically what B and C have. So you basically just go to set B and C and you just shade the intersection. Okay, even this other intersection that is kind of in all 3 of them is part of the same thing. That's 1 mark. Of course, nothing to be afraid there. Question 10. Now this is a question that deals with limits of accuracy, and it's important that you understand that this is already some sort of limit there. So you're not going to do any rounding in your answer. So they are saying you're supposed to subtract. So what you need to do is, whenever you want to find the largest value, in this case, what that means, it is the upper bound. And the way you calculate the upper bound is you take the upper bound of the number n and you subtract that with the lower bound of the number w. Okay, so since all of them are to 1 decimal place, that's 0.1, you go ahead and you divide by 2, you get 0.05. So basically, to find the upper bound of 7.3, I will be adding 0.05, so it's going to be 7.35. To find the lower bound of 3.1, and this is very important, I'm going to subtract 0.05 from 3.1. So that's going to give me nothing but 3.05. So 3.05, okay? So that's the lower bound. Lower bound here, let me put a B there so it doesn't get confusing, the lower bound of that number. Okay, so punching that in gives you nothing but 4.3. Okay, and that's it, and you're done there. Wahuma bought a music player for 345 Namibian dollars, and then the person sold it for 285. So obviously you can see that the person made a loss, and let us just determine what that loss is. We're going to say, okay, that loss is nothing but the 345 take away 285. Of course, that is a loss of 60. So some instances you might get a mark for that. But to calculate the percentage loss, you put that actual loss over the original price, over the 345, what the item cost before. You can multiply that by 100. Okay, and you can use your calculator, of course. Let's say, okay, so this is going to be 60 60 upon 345. Well, hit that, and you can simply multiply that by 100. Of course, you get 17.39 and stuff like that. Of course, that thing goes on and on and on. So I'm going to just say 17.4, okay, because it is not an exact number. All right, so your calculator was 17.39 and so on percent. But of course, I would be giving this answer since that is not an exact answer. The school club invested 2,500 in a bank. So that investment, that is called your principal. And the 8% is called your rate. And you have got simple interest. So the formula is quite straightforward. You take that principal and you multiply it with the rate. And we want to find the time. So I'm going to say times t, where t is my time. And we know that we are generating an interest of $800. So basically, something t equals to 800. So you can go ahead and you can sort of work out the numbers part first. So you can say 2,500 times 8%. Because that gives me 200. So this brings me to 200t is equal to 800. I think from this point onwards, you can clearly see that you should be able to calculate that this is 4 years. Okay, quite straightforward. Of course, we expect you to know the formula here. Simple interest is equal to the principal times the rate, which is always 100, and times the time. That's why that 100 is there. So that's what that 800 is equal to. Question 13, well, they are saying you are supposed to convert 0.6 meters per second into kilometers per hour. Let me show you a cool trick with this calculator. So it has got a conversion. You see here on top of the 8, there's conversion. So if I was to press shift and I say conversion, of course, there are different conversions that take place. So there are about 40 of them. But if I hit 20 and I put 20 in there, the calculator is ready to convert meters per second to kilometers per hour. So I just have to go ahead and put in 0.6 over there. So I'm going to hit 0.6 and I hit enter and it gives me the answer as decimal 2.16. Okay, so this is 2.16. However, you're not allowed, your calculator, the one that you have, will not have this particular function. So let us see what is an obvious way of doing that. So 0.6 meters. So let's first write what is 1, because you have to change it to kilometers. So it's like kilometers over hour. So we know that 1 kilometer is equal to 1,000 meters. And we also know that 1 hour is equal to, very important, 3,600 seconds. So that means if I have 0.6 meters, so that's 0.6 meters over 1 second, I'm going to change. So moving from meters to kilometers, I'll have to divide by 1,000. And if you divide 0.6 by 1,000, so that means you say, okay, let's take the 0.6 and we divide it by 1,000. That's going to give me 0. Of course, you can always change this so that it can be to normal mode. And I'm going to hit 8 and I'm going to choose 2. Okay, so the calculator now will give me 0.3 zeros and then 6 there. So it's 0.123. So now this is in kilometers, okay? 1 second is 1 second of 3,600 hours. So that's what that is. Okay, so basically you can just go ahead and punch this in. Of course, again, as I said, there are many ways that you can do this. As long as you know the method that you're using, 1 over 3,600, of course it will give me the same answer. Can you see that? Changing from into decimal form give me 2.16, which is the answer that I got from that other method. Okay. Question 14, of course, I don't want to rush the paper, but you can obviously always pause and try and solve this question. So you've got the ratio of zinc, tin, and copper. So you have got 1 part zinc, you have got 4 parts copper, and tin, rather, and then you have got 95 parts copper. Okay, now they are saying a bronze statue contains 120 grams of tin. So what I'll do is I'll put that 120 under the tin. Okay, that's where the tin is. All right, so this one's here will be unknown. So they want to find the total mass. So it's what x is, what y is, the sum of x, y, and this 120. But that 120 is very interesting to me because I either had to multiply or divide, multiply by something, gives you 120, and what that is, it's 30. Can you see that? So if you were to multiply here by 30, you get 120. So just go ahead and multiply everything by 30. And when I hit 95, and I say, okay, 95 times 30. Okay, so I know the parts for copper, 2,850. So that's 2850. And of course, if I hit this one times 30, that's nothing but 30. Now, you simply go ahead and add to find the total mass. 30 plus 120 plus 2850. Of course, this 150 added to that, that gives you 3,000 grams. That's the total mass. Of course, there are many ways you can do that as long as you find the correct answer. Right, write down the gradient of the line. So in this question, I would advise you to rewrite this in the form y equals to mx plus b or plus c. Okay, we're going to use c. The m value is our gradient, so if I was to rewrite that, it's y equals to, it's now minus 3x comes in front of the positive 8. So the gradient m is equal to the gradient, so the gradient is nothing here but negative 3. So write it in gradient intercept form. Now this question here, they say find the equation of a line that's parallel to this line. So the thing about parallel lines, and I think I have maybe a method here. Parallel lines are lines that have their gradients are equal. So what you can see is I got the line y equals to 3x plus 8, and I drew that line. That's the line that we have. But they want a line that is parallel to this line, so therefore their gradients will be equal. As you can clearly see that this minus 3 and this minus 3 indicates that the gradients are equal. The only thing that will change is where the lines will cross the y-intercept. Now taking the point 1, 1, x is 1 and y is 1, and substituting it into this formula here. But I'm going to say use y equals to minus 3x plus c, because we don't know what the y-intercept would be. So I'm going to substitute my 1 here and my 1 here for x and y. And that's what I did over there. And this allowed me to find the value of c. So the equation, the new equation is y equals to minus 3x plus 4. And as you can see, once I plotted it, that these gradients are exactly parallel. They will never touch. And that is the equation. And that's the answer to 15b. So I'm going to go back and I'm going to just write it in there so that you can see. So this answer here is nothing but y equals to minus 3x plus 4. Of course, I had to substitute my 1 in for y. So I had to say 1 over here equals to minus 3 times 1 plus c. Eventually leading me to an answer of c equals to 4. So c equals to 4, and that's what you can see over there. And you write down the equation because the question is asking for the equation. Right, question 16. Again, it says the diagram shows the net of a solid. Now, of course, this is the net is open one. So I've included the diagram over there. So you can see that this diagram here is referred to as a square because the base is square. Okay, so it's a square based pyramid. Okay, it's a square based pyramid. That's what you have. So I have got a few definitions over there. You can also call it, of course, it's not something that will be biblically taught at school, but you can also call it a pentahedron over here. But let us just stick to what we know. Okay, let's stick to what we know, and we do not have a problem. Okay, so of course there is also additional information. He says it has got 5 faces. Okay, as you can see, that's face number 1, number 2, number 3, number 4, number 5 faces, and also 5 vertices. Now the vertices are these sort of where the faces are coming together, or the edges. So this is vertex 1. So that's 1. That's going to be 2. Okay, I'm going to come to that one. That's going to be 3. That's going to be 4. So where will the other vertices be? I mean, 5 vertices, including the apex. So where will the other vertex be? Because the question says, for this solid, write down the number of vertices. Okay, so you will not be able to see it from here. So that's a very wrong approach for me in terms of the vertices. But if I was to look at the solid that is there, the vertices is going to be the apex, as I was now indicating over here. The apex is here, so that's going to be 1. And this is 2, 3, 4, and the 5th one is right over there. So those are 5 vertices. And basically that's what the second part of the question was asking you. For this solid, write down the number of vertices. So it's not going to be possible for you just to see it from there, because you might be tempted to count as I was now doing it. Right, question 17. Now, when they're asking you a order of rotational symmetry, what does it mean? It should be said to have that symmetry or a certain order if the plane figure maps onto itself, or you look at where the center is and you sort of rotate it, at few angles, and then the shape looks exactly identical. So maybe I'll come here. So let's take this shape over here. Now it will be very difficult for you to see, but you need to be able to look either at this little triangle here or this one. So if I was to rotate this, let's say 90 degrees, it will be somewhere there. The shape didn't coincide on itself. It didn't look exactly the way it was. So that's 90 degrees. Now if I have to go back again, another 90, that's 180. Can you see that the shape exactly now looks? So 180 degrees, that is 180 of the 360, so that's 280 degrees into 360. Okay, so I redrew this here again, just maybe for that illusion to be away. So think of this triangle, or this one. So if I was to rotate it 90 degrees, yeah, something like that, it will not coincide with itself. It will not look exactly like this. Okay, but if I were to go again another 90 degrees, so I'm now at 180. So can you see that? Just ignore the shaded part, but now the shape exactly coincides with itself. So we say that this shape here has got order of rotational symmetry of 2. Okay, so the question was asking us, write down the order of rotational symmetry. Okay, let's just wait for it to do its thing, because I have now been scrolling and scrolling. Let's see if it will bring me back to where I need to be. Okay, well, you can take a short break, or you can go back to the work that I have explained previously until this thing can now get to a halt. All right, so I'd like to take another short break then, if that's the case, giving you the opportunity to, okay, let's see. I think we're back on. So it's a new year coming with new challenges. All right, so write down the order of rotational symmetry. Now, very important here that you do not mess this up. Don't write line, just write 2. That's the order, is 2. That's it. Okay. Question 18, it is given that vector t is equal to -4, -3, and vector s is equal to -2, 1. So of course, when you are adding them, you just add the component parts. So -4 plus -2, that gives you -6, and -3 plus 1, of course, that's going to give you -2. So that in itself is the answer for 1 mark. Don't even bother to waste your time. Now, when they are talking about vector t, now you're looking at vector t. Vector t has components -4, -3. So I'm going to go to the diagram over here. So I want to explain to you what this vector is called, a free vector. So here I drew vector t for you. Now remember, vector t is nothing but -4 in the x direction, okay, and -3 in the y direction. Okay, so x direction means goes to the left, and minus here means it goes down. So if I was to represent that vector here, it will be from here. If I started at the origin, okay, so now I say that I call it vector AB or vector t, as you can see, it will be -4 in the x direction because it's negative, and then -3 downwards. Can you see where now that is where it is? But I could have started this vector at any point. It's a free vector. It's not a position vector. It doesn't start from the origin. So I started, for example, here. I choose any point here. So if I was to choose a point here, I call it vector u, for example, and I have to go four places in that direction, and come 3 places down. So we are interested at that diagonal line, the distance there. Okay, now in order to calculate that distance, it's like you are creating a right angle triangle. I don't know if you can see that. It's like you are creating, can you see that, a right angle triangle? And to do that, we have to apply Pythagoras, okay, in order for us to find that length there. And to use that Pythagoras, okay, in fact, I just want to show you something very cool where I can actually use the software GeoGebra, which you can download, of course, to calculate the distance there. All right, so I'll be going, let's say we come here. So I'm going to say the distance of the length. So they say select 2 points or a segment. So if I was to select this point over here and that point over there, can you see it tells me the distance is 5 units? The same, if I was to put that point over there, this point over there, can you see the distance is nothing but 5 units? All right, but you don't have the software in the exams. Okay, can't say, yeah, it's just like that. So what do you use? Of course, I already alluded that you must use Pythagoras. So that means if I have to go back to the problem, and I took that little diagram and I put it over there, so you'll be saying that the distance there is going to be, the magnitude is going to be, well, you can put -4 in brackets square plus -3 squaring, and then you can put all of that under the square root because it's Pythagoras, okay? In fact, you don't need, since it's distance, you don't need to put these minuses there. It could be a bit tricky, especially if you use a calculator and you don't open these brackets there and the calculator gets confusing, and then you end up giving incorrect answers. And if you were to do that, and by now you should be very familiar with the 3, 4, 5 triangle, in Pythagoras, adding that should give you the answer of closing it of 5. Hit enter, can you see? So it's 5 units as we have determined. Okay, so you can't have a negative answer under this root. Anyway, I thought the illustration is going to help as I continue with this question. Let's come to the algebra part. Now that was a lot of numbers and stuff like that, but quite straightforward to an extent. Before I continue, I just want to bring this page in. This is what well, of course, let's take a small break and then I'll come and explain that again. Okay, so welcome back. So what I did, and you are going to get, I'm going to release a booklet, and this booklet will contain the question papers in mathematics that was written since we introduced this system to you from 2020. That was the first time, so obviously this course was introduced in 2019, and 2020 is when the first examination was taken, 2021, and then the paper was rewritten, so there's another paper, and 2022, 2023, and 2024. So all in all, you have got 6 question papers that you're going to get with my solutions and also with links that take you to my YouTube channel, as you have seen me working out these question papers, and I'm now busy with the ones for last year. And what I did is I took the topics and I summarized them. So maybe as you take, you might have slightly a bit off from me or so on. But what you need to realize is that looking throughout the years, the number of marks, so paper 1 is consisting of 80 marks, okay? So let's say in 2020, of those 80 marks, 31 of them was just on numbers and operations. That's about 38.8% of the question paper. 34 marks in 2021 and so on. So as you can see, these ones indicate that in that paper there was nothing. In 2021 there was nothing on set language annotation in paper 1, perhaps in paper 2. So this is a summary of the topics and the percentages they referred to. And in the bottom here I indicated that numbers and operations and geometry and algebra, they carry the most marks. It doesn't mean you must necessarily just focus on them. Okay, but it means that you should not overstudy a topic where you're not going to get a lot of marks. You have to work smart. Okay, so you'll see that set language, and you'll see in this paper, of course, it is only 1 mark under that topic, measures 4 marks, and geometry, algebra, can you see it carries quite a lot of marks. So this paper was also well balanced this year. As you can see, of all the 12 topics that we have, there was a question in all of them. Okay, to an extent. There were years like they didn't have bearings and trigonometry in 2023 and so on. Okay, so that's paper 1. Of course, I have done the same thing for paper 2. And you'd also see, if you look at paper 2 again, of all the 12 topics, well balanced this year because every topic was considered. Now, these are all things that are going to be in that booklet, and it will be ready by the end of January for you to use at schools with my explanations. And what you have over here are the topics, the 12 topics that you need to know for grade 10 and grade 11. So you work smart, do not study the textbooks. You are supposed to look at your objectives, and you have to make sure that you understand and work through these question papers, and don't do exam style questions and stuff like that. So if you look at the percentage, the ones that carry the most, you see this 19.7, that's topic 6. And if you know what topic 6 is, obviously topic 6 is algebra. Can you see that? Since they have so many competencies or objectives, they would naturally carry the most marks. Okay, topic 18 or topic 7, which is your 11.8% here, topic 7 is functions and graphs. So, of course, this summary is going to be in that booklet with all these question papers and the mark schemes from the government, with permission, of course, and my explanations and hints, and you can use that as an examination buster. Okay, let's get back to our question paper. So they are saying factorize completely. So this is question 19. So please do not do partial factorization. The emphasis here is completely. So look for the highest common factor of 15 and 3, for example, and the highest common factor of a cubed and a square. So of course, highest common factor implies the number that goes into for leaving a remainder. Of course, 3 is the highest common factor of 3 and 15, and the one with the smallest power. So that's your common factor, and that leaves you with 5a minus 1. Of course, you can always multiply back and expand, and you see you will end up exactly at the same answer. Question 20, this is a linear equation, which means it has only one solution. Now, perhaps the advisable thing first, put brackets over there, and then move that 2. Okay, so you're going to have 5 all over x minus 1 is equal to 12 minus 2. Now we know what 12 minus 2 is, so that's going to be 5 over x minus 1 equals to 10. Well, you can go ahead and put that 10 over 1. And you can sort of use different methods here. You can sort of cross multiply and see where that brings you. So if you did not close those brackets, then you will have totally something different. So this is going to leave me with a 10 over here. I've got x minus 1 is equal to 5. So from here, you can pretty much do anything. Of course, I could be expanding this over if I want to, or I can divide by 10. Okay, so this is going to give me x minus 1 is equal to a half. Guess what? If you now have to move that minus 1 over again, it's going to be x equals to 1 half plus 1. What is 1 plus a half? Well, that's 1.5. Okay, or 1.5, whatever. Whatever method you decide to use, you still arrive at the same answer. Okay, but it's important that you do show a lot of your working, because this is where you're going to gain marks and so on. Okay. Question 21. All right, you got to simplify again. So recognize that this division can be changed to, so first you write the first one as is over 2. Change that to multiplication. And then what you do is you invert, you take the reciprocal of the fraction that follows that multiplication. So the 3r squared s will be under, and so on. So from here, you can just go ahead and do your simplification. So in most instances, for you just doing that might already maybe give you some marks. So obviously that goes in here 2 times, and the r cancel, cancel with this one, the s cancel, and it's going to give me a 2 over there. So I know it's a lot of work, but now what I'm left with is 2s squared for the numerator, 2 times that, over 3r, over 3r. Whatever method you apply, as long as you get to that part. Of course, you could also, go ahead and multiply out if it looks a bit too confusing, and then you can get to the answer, which is 2s squared over 3r. Question 21, somehow nice algebra, although it's proportion, but there's algebra involved, okay? Directly proportional, they say x is directly, so x is directly proportional. Why did I write that twice? Is directly proportional to y minus 1 all squared. You don't have to write that down. So what does it mean? In the equation language, we have to have x is equal to some constant of proportion times y minus 1 squared. So they are going to give us now, these values that they give us here are now the values I'm going to input, because I need to calculate what the value of k is. X is 8, so 8 equals 2. Some constant, y is 3, so put 3 minus 1. You do not have to multiply this 3 or y minus 1 times y minus 1. Just put in the values, okay? 3 minus 1 is 2, and so this is 8 equals to k times 2 squared. All right, so let's create some space more. So now I'm left with 4k is equal to 8. So that implies that k will equal to 8 divided by 4. So my k is equal to 2. So naturally, this is where my equation is. And I'm going to write it. So it's x equals to, my k is 2 and y minus 1. So now that I have my equation, I can now calculate either x or calculate y. So whatever they are asking me, they are saying calculate the value of x. And they give you the value of y. So you're going to go ahead and say, okay, x would be 2 times, what is the value of y? Well, the value of y is 12. So you put 12 in here, minus 1 gives you that. Now that is nothing but x would be 2 times 11 squared. Now 11 times 11 is 121, and 121 times 2 is 242. So the answer will be 242. There you go. So showing most of that working, especially having the constant of 2 there, constant of variation or proportion, that yeah, you would be able to generate some marks and so on. Right, question 23, of course, here is another question. Now, the moment they are asking you to find an unknown, and the unknown is an exponent, it most of the time means you have to use exponential equations, or you have to use logarithms. Now, there are many ways you can do this. Since I can't make 130, I can't express it as a base of 2, so it's going to be pointless. So what I was now saying, if I had something like 3 raised to the power of x is equal to 81, I do not have to use logs here to solve this. I can simply say, wait a minute, 81 is nothing but 3 raised to the power of 4, okay? And you should know that. So 81 equals to shift, use that fact, gives you that, okay? Or you express 81 as a product of its prime factors and so on. So once the bases are the same, it implies that the exponents are equal. So in this particular case, no problem, we can do that. But there's no way I can write 130 as 2 raised to the, in fact, the closest one would be 2 raised to the power of 7, which is 128, and 2 raised to the power 8 will be totally something else, okay? It's double that, it's 256. Okay, so it will not work. So what is it now that we can use? Well, of course, we have to bring in logarithms, and logarithms allows us to solve this. Again, there are so many ways. Some people are splitting these, but this can be done. But go ahead and write that 2n plus 1 in brackets over there is equal to 130. And then you go ahead and you take logarithms of both sides. So that's going to be 2n plus 1 over there equals to the logarithm of 130. And then you use the power law, so that exponent comes in front, so that's 2n plus 1. And dropping that gives you log of 130. So from here, you are now trying to isolate the value of n. So we're going to do it step by step, and then the way you're going to go about it, you're going to say, okay, 2n plus 1 is going to equal to log of 130 over log 2. Okay, so that's basically just going to give you some calculator value, whatever that is. So I'm going to have 2n is equal to, whatever this answer is, log 130 over log 2. I'm going to take away 1. So I'm going to go ahead and use my calculator now, since it becomes a little bit too much. So I'm going to say, okay, log of 130 divided by the logarithm of 2, whatever that answer is, and I'm going to take away 1 from that, minus 1. Of course, it'll give me 6.022. So I was going to have 2n is equal to 6.022. Let's bring in some more values, 367, and so on. Now, of course, to have n alone, I'll have this horrible answer must be divided by 2. Okay, and if I was to do that, go to my calculator, I'll say, okay, well, divide by 2 that answer. Okay, so 3.0111 and so on. So there I have my answer. So my answer is going to be n equals 3.01. Since it continues, I'll just write it to 3 significant figures. Again, a lot of work that I have shown there. I could have taken a different route. I could have split that 2n plus. I could have had the different thing, 2 raised to the power of 2n plus 2 raised to times 2 raised to the power of 1 and stuff like that. As long as you get to this answer. Simplifying and expanding, okay, there are many ways you can do this. You can either simplify or expand this x minus 3 first, and there are many ways you can go about it. So you can go ahead and say, okay, wait, that x times that x gives me x squared, x times minus 3 gives you minus 3x, minus 3 times that gives you another minus 3x, and a negative times a negative, or be very careful, minus, it's plus 9. So I'm going to keep it in brackets because there's still a further multiplication I need to do. But before I start multiplying over, let me just write that 3x plus 1 in front. Doesn't matter where it is, but it's just easier. Minus 3 minus 3x is going to be minus 6x plus 9. Makes it easier for me to illustrate. So again, I go, that gives you 3x cubed. That 3x times that gives you minus 18x squared. That 3x times 9, 18, 27. That gives you plus 27x. So let's come to the second term. So we have got 1 times that. Of course, 1 times anything is just going to be that. And then we have 1 times negative 6, that's minus 6x. And you have got 1 times 9, because that's going to give you 9. So we can actually clean this up with looking at the like terms. So 3x cubed is just 3x cubed. But if you're looking at the like terms, you would see that this minus 18x squared and this one, they are family members. You can also say, okay, this 27x here, the positive 27 and the minus 6x, they're family members. So let's just go ahead and finalize our answer. And our answer would therefore be, the final one would be 3x cubed minus 17x squared plus 21x plus 9. Of course, the minus 17x squared comes from minus 18x squared plus 1x squared. And 21x comes from 27x, take away 6x. And there's nothing you can do with the 3x cubed and the plus 9. So that is the final answer there. Okay. Right. So that brings me to question 25. So we're going to have a little bit of graphs here. And I have completed the table, but I've also interestingly added a different value. So ordinarily, if you get this, you will realize that 2.5 is not there, but I have just added it there for effect. And the more points I have on a smooth curve or on a curve, the smoother the curve will be. Okay, the more points I add to the function, the smoother the curve will be when I have to plot it. So how do I get these values? The missing ones for 2 marks was the 2.5 and the 3.2. So naturally, you just grab your calculator and say 6 over. So what are the values of x that they're giving me? So in this particular case, x is 4. So you say over 4. You go out, you say plus another x. What is the x? Again, 4. take away 3. So once you hit that, you get 5 halves or 2.5. So that's where the 2.5 comes from. And then you simply just go back on your calculator. Now you need the different value of x, which is 5. So just go ahead and replace all of that with 5. And again, 16 over 5, which is the same as 3.2. So that's where they are coming from. So these are coordinate points. When x is 1, the value of f of x or y would be 4 and so on. But I added the 2.5 because 2.5 is halfway between 2 and 3. Can you see it wasn't there? I just added it because I wanted to find what halfway would be. So if I was to take x to be 2.5, for example, you don't have to do that. Okay, I just added it so that it could help me with the construction. You see I get 1.9. So now this one's in red and this one here, the 4. So 1, 4, 2, 2, 2.5, 1.9 and so on. I'm going to plot them and I've already done them here. So I've plotted it. I'm just going to make it a little bit smaller so that you can follow. Okay, right? Not too small though. Okay, so you would see if you follow from your graph, when x is 1, f of x is 4, and I've plotted it. When it's 2, yeah, 2, 2. Now I brought in the 1.9. Can you see I even indicate with the arrow? And 3 is 2, and 4 is 2.5, and 5 is 3.2. Very important that you also know what does one small block represent on the y-axis, and so that you don't get confused. Right, so once you have plotted the points as I have done, the only thing left to do is to join them, and it's a curve, so do not use a ruler. All right, so again, this is freehand drawing, but in your examination, you probably should be drawing a much smoother curve. Let's see. So you use the inside of your palm, and you just join them. Okay, always anticipate where something will be. I might slightly off there, but yeah, that is the function. You can now label it if you want to, but this is f of x. That's what the function is. And you have plotted. Of course, you get marks for plotting. You get marks for the smooth curve, 1 mark. Okay, so do not use a ruler whenever you do that. That's it. Please do not continue with this. If you continue and it passes the f of x, this is the y-axis, and this here, if you pass the y-axis, then x is equal to 0. And x cannot equal to 0 in a function because you cannot divide by 0. So this will not be existing anymore. In fact, as this thing goes, it gets closer and closer, but it will never pass that graph there. Okay, and so on. So it will be a smooth curve, and this one continuously rise and so on. Okay. Right. So question 26. The diagram shows an irregular polygon. So what I've done, I've indicated here very clearly that this is not to scale. So please don't work on this diagram with the idea that you say 110, that is something, I don't know, people go and they divide these, they say, okay, this is going to be a triangle over there. Don't do that. This diagram is not to scale. So what you can do, there are two ways. The exterior angles of any polygon, the angles on the outside, will add up to 360. So naturally, if I was to find that exterior angle over there, this exterior angle over here, maybe this one over here going like this, and perhaps I can have this one over here. So what I'm saying is, if I was to take this exterior angle plus that, and the reason I put x's there, they will be the same because, you know, the angle QQ is the same, plus that exterior, plus that exterior, and so on. All of them, as you can see, will give you 360. So that is what I did there. So you can actually calculate these exterior angles. So you know that if the interior angle is 110, then this one is 70 because they must give you 180. This is 111, so this one will be 69, for example. This is 105, so this one must be 75. This is 112, so this one will be 68. So what I did on this other part, so this is the part that I want you to focus. So I said 69 plus 70 plus 68 plus 75, which is those exterior angles, plus the two identical ones, gives me 360. Right, so when I do that, I'm going to find what my exterior angle eventually will be. it will be x, this little angle will be 39 degrees, okay? So this little angle here will be 39, and so would this one, by the way, also be 39, okay? But I'm not interested in that angle x. I'm interested in what is that interior angle. Now, interior angle plus exterior angle of a polygon, they will always equal to 180. So in order for me to find my answer, I will just say, okay, the interior angle will be 180 minus that exterior, which gives me 141. Or you could use another fact. Looking at this diagram, it's a hexagon. And a hexagon, this is an irregular hexagon, by the way. Okay, not all the sides are equal. The sum of the interior angles, this 105, 112, Q, 110, 111, and this Q, all of these, they should add up to. So it's 180, then it's 6 or 6 minus 2. Okay, this is going to give you 720. So it means all these angles inside, as I have indicated, Q plus 110 plus 111 plus 105 plus 112 should equal to 720. So I hope you're very familiar with that. Now I could equate all those interior angles to 720. Find the sum of those ones is 48. Q plus Q is just 2Q. And then solve, so 720 minus that, and divide that by 2. So that is also one way that you can find that particular answer. I think naturally for me, this would be the most common one that can be used. Okay, now I just brought in the diagram and I drew it to scale. So I used the software so that you can see how that diagram actually looks. Right, and you can see that this diagram is fundamentally very different from this diagram. This diagram is not to scale, so its scale version will look like this. And can you see where the 141s are and stuff like that? So if it was to scale, then you could measure. You can take a protractor and measure, and you will see, oh, this is true, this angle is 141 and so on. But if I was to take a protractor and I measure here, it might not be equal to that because this diagram is not to scale. So you can't be using the diagram and say, okay, I can bring measurements here, I can cut these into rectangles or whatever the case may be. Don't do that. So the purpose of this task was for you to use the properties of a hexagon, like for example what I did here with the 720, or the exterior angle property theorem, so to speak, for you to be able to calculate that value of Q. Right. Question 27, of course, they say on the grid above, draw the lines x plus y is equal to 5. So it's a straight line starting at 5, 5. So the reason why that line is there, so I took x plus y equals to 5. And I decided, okay, let me make y the subject formula, y equals to 5 minus x. Okay, if you take the y over, the x over. And I have my table. So I took a table from x from 0 to 5, no, from 0 up to 5. And I said, what is my output? So if I put 0 everywhere, x, I have a 5. If I put 1 here, I have a 4. If I put 2 here, I get a 3. So all these points, if you plot them, you only need 2 points, in fact, to plot, you'll get this straight line. So in fact, any line x plus y equals to some number, it should be very equal to draw. So if the line was x plus y equals to 4, it will go from 4 to the other 4 that side. Good. The second one that was challenging is y equals to 2x. Now this line, I made my table here. I say y equals to 2x. I say, okay, right, let me take a few points. I take 0, 1, 2, and 3. Okay, 0, 1, 2, and 3. Okay, I didn't want to go far because it would be outside of that. Now, on my table, if I say, okay, if y is x equals to 0, what's y? Of course, it will be 0. If x equals to 1, what is 1? It's 2. If x equals to 2, 2 times 2 is 4, and so on. So I have these points. So I can plot these points. 1, 2, 1, 2, 2, 4. So it's 2, 4 all the way, and 3, 6. All right, so now that I plotted, I can draw that line. So that's how that line should have looked like, okay, if you were to draw that. Now, the shading comes, and this is important. If you look at the inequality, because it says by shading the unwanted, so drawing those 2 lines, of course, it gives you 2 marks. Now they say you must shade the unwanted regions, indicate clearly the region where x is greater than or equal to 0. Of course, that one is not necessary because it's on the other side if you were to do your shading. x plus y is less than 5, and so on. So let's focus on the less than. Y is less than 2x, less than or equal to 2x. So when you have, not less than, sorry, this is greater than. If you have inequalities greater than, the wanted region will be above. So the line y equals to greater than 2x, this one here. The wanted region is above, is this one here. So I'm shading below. So essentially I was now shading below. Can you see that? And if you are dealing with an inequality of less than, like this one here, x plus y is less than or equal to 5. For less than inequality, the wanted region is below. So the less than, the wanted region is below. So I will be shading the unwanted region, which is that part in pink that I've shaded. Eventually, this one here, x is greater than 0. So the wanted region is, because this is just x equals to 0. If you take an equation, x equals to 0. So the unwanted region would be this side. So there's no need for me to shade that. So the region that satisfies all of this is this region that is in white here. Okay, that is the region that satisfies this particular. So if in some instances we ask you to write an R, you will do that. Okay, take note of that. So I'm going to just stop there so you can take note of these notes and so on. Of course, it will help you naturally if you have the question paper at your disposal somewhere in the year, and then you see how I work it out. Hence, I'm talking about that booklet. So when you have it, you can also work these things out. You come back to my videos only if you are a bit unsure about a question here and there. All right, that brings me to question 28. Now, I have actually drew the diagram here. They say you must leave all the constructions. They say using a ruler and compass only construct the locus points which are equal distance from PQ and PR. Can you see that you have 2 points, PQ, PR? What do they share? They share that P. So that is the intersection. So it means we have to bisect this angle. And this was exactly a similar question in last year's. So that blue line. So how do I do that? So of course, let me just come to my, what you call it, to my drawing. So let's suppose I say, okay, let's get rid of I just want to move the diagram somewhere. Let's just get rid of the stuff that we have so far. Okay, and then you follow with your instruments. You follow with your instruments. Okay. Right, let's bring our diagram back. Okay, so that's our diagram. So what do? You take your compass, okay, you put it here at P. Of course, you can open any that you want, okay. I can make it in fact smaller if I was to do that. And then you make yourselves, let's bring it in maybe a little bit like this. And you make yourselves an arc like so, okay. Once you have moved that, now once you have done that, now put it at this ends here. Put it here, and you put it here. Okay. So you can actually make this thing a little bit bigger. So I will make it a bit bigger because I want it to be on the outside. Okay. And let me also perhaps change the color. Let's see if I can change the color of this one. So if I was to see if I was to change the color. Okay. All right. It's tricky. Let's say we bring it in here. Let's go back to our board. Okay, let's go back to our board. And mind you, now the big question is what happened to my tools? Anyway, let's bring our tools back. Let's bring my compass back. All right, so there's my compass. I'm going to put my compass over there. Move it slightly. It's a bit challenging, but it's something you shouldn't struggle with. Okay, I can put it here. All right, so I said I want to make this one slightly bigger. Okay, so let's make it slightly bigger, more bigger. All right, so I'm going to make it okay now, like so. All right, so let's make that red. So when I do that, so okay, let's see where it makes, and I take my compass and I put it on the other side. Let's go put it back there. So let's bring it back. Okay, let's see where do they meet. Okay, I think it will not hurt if we were to start over. Okay, let's start over. Let's bring my diagram up at this side, and let's take our compass. We're going to put our compass at P because we want to bisect that angle over there. Let's make it a little bit smaller. We'll just see how. Right, so now we can actually do it. Okay. Don't know whether it's actually bisecting the correct place. Okay. Seems to be a glitch with my software there. If I was to move it. Okay. Well, I can use the same, or I can change this slightly, but I'm going to use the same. So I'm going to put it then on the other one. And of course then, oh my goodness gracious. Let's start all over. Okay, it's one of those things where you have a small glitch or a small. Okay, let's bring our diagram closer by here. Let's bring this guy in here. Okay, let's have smaller, maybe slightly smaller. Let's have, okay, smaller up to there. Let's have that bisecting that. Then we move over there, and perhaps we can make it a little bit open, a little bit big. Okay, then we're gonna have that over there, and we're gonna move it again. So we're gonna have that. Good. Now that I've done that, I'm gonna bring in my ruler. So let's bring in my ruler. Of course, I'm gonna bring in my ruler. I'm gonna extend it a little bit, and I'm gonna join. Can you see where it crosses? Right. Extend my ruler again. Of course, I can draw. Bring it back over there. Very important that you put your ruler at the right place. Let's see. Okay. Let's see if it's going to draw. My goodness. Wait. Okay, there we go. All right. Okay, so I have bisected it. So place that bisected there. So that's the angle bisected. And you leave these constructions, okay? Right. Anyway, that's what I have done over there, and that's how it's supposed to look like. Now, it's very important that, again, as I said, that you do not rub off these constructions. Okay, that does it for question 28. Let's continue with question 29. Okay, remember I said there are 34 questions there. We're very close to the end. Right, the determinant of this matrix A is -1. So how do you find, or how is the determinant? What is it? How is it calculated? So I've put vector A's A, B, C, D components there, and the determinant would be, and this is the way we write the determinant of that. Okay, or there are many other ways, but it would be you take the A component and the D component, you multiply them together. You take your B and C components, you multiply them together, and you subtract that from the two. So when I use that logic, it means my A here will be 4. So I will say, okay, 4 times 2 minus A times 3, or 3A, should give me -1. That's basically what it is. So this is 8 minus 3A equals -1. That's 8 plus 1 equals 3a. Of course, I moved the terms over. So I have 9 equals to 3a. Of course, naturally, you can find the value of a by simply saying a would be 9 divided by 3. So a is equal to 3. Okay, social I'm working, and you should be able to be fine. Good. Question 30. The diagram shows a cone. So I have added this triangle. So what I did is I sort of separated that from the diagram. Okay, and they ask us to find h, and you can see that this is a right angled triangle, so that means we have to use Pythagoras. And since we are looking for a short side, we are going to subtract the square of the shorter side from the square of the hypotenuse. Hypotenuse being 6 squared minus 4 squared. So when you look for a short side, you subtract. Say the hypotenuse is always opposite the right angle, so it's the longer side. Right, anyway, from here on, it's just a matter of you calculating. 6 squared is 36. So this is 36 minus 16. Okay, of course, you can have h squared, 36 minus 16. Well, of course, that's 20. So h would be the square root of 20, which you get 4 times 5. So it's 2 root 5. Or you can simply just go ahead and use the calculator. Okay, so that is going to be the square root of 20, 2 root 5, and then you can change it to 4.47. So you're allowed to give your answer in this form, or 4.47, since it's a number that is not exact. You will definitely have to give your answer to 3 significant figures. Then they say calculate the curved surface area of the cone. Now, the nice thing about this course, they do give you the formula for the curved surface area. So the curved surface area is pi times the radius times the slant height. In this particular case, the slant height is the 6. That's the L that is there, the 6. So it's just a matter of punching in. So what is my radius? My radius is 4. What is the slant height? Well, it's 6. So 4 times 6 is 24 times pi. Of course, now you can just punch that in on your calculator if you wish to, but I'll just leave my answer as 24 pi. This is an exact answer like that. Otherwise, you find out what 24 pi is, and you then give your answer to 3 significant figures, 75.4. So another student could be writing 75.4. That would be 3 significant figures, of course. Okay, question 31. So you have got the area of a triangle. They say the area is equal to 21.3. AC is 8, as you can see. BC is 12, and then they ask you to find the angle ACB. So this particular angle over here. So this is the angle that we need to find. Now, I have written the formula down for you. How to find is another formula, how to find the area of a triangle. So if you have got the angle, you've got a side, angle, side. You can calculate. Okay, abbreviate it shortly like this. So I'll be saying, okay, a half times 8 times 12 times the sine. Let's say, do we say that angle is theta, is equal to, the area was 21.3, it's given. Okay, that's given. Now from there, it's simply a matter of you punching it in and finding what is that. Okay, a half times 12 is 6, that is going to be 48. The sine of that angle equals 21.3. Of course, might be running out of space a bit. Let me see. I'll have sine theta equals to 21.3 over 48. Remember, this has to be a proper fraction. My angle ACB, will be the inverse sine octave of whatever this answer is over here. Okay, so because I'm looking for an angle, I have to use the inverse button. So I'm going to say that inverse sine of 21.3 divided by 48, okay, and that hit enter. Now remember, they say when you right in the beginning, they say if you are dealing with angles, then you must give your answer to 1 decimal place. So this is 26.3. So here, 26.3 degrees. This is our solution. Okay, so I also have taken the liberty of writing the formulas that you are coming across that you must know, and you use that formula in order for you to calculate, um, you know, whatever they count. In this particular case, they want you to find not the area, but that angle there. Sometimes they want you to find the area, they must give you the sides, and they must give you an angle that tells you what is that angle there. Question 32. The diagram shows a water trough with a semicircular cross-section with a radius of 20 centimeters, a length of 120. The trough is full of water. You're supposed to calculate the volume of the water. Now, I did the same thing. So I put the trough over here. It's a little bit more, diagram is more, makes more sense. The volume of a cylinder is pi r square h. That's the volume of a cylinder. So the volume of a cylinder will be pi. This is a cylinder. But now the volume of this trough, which is a half of a cylinder. So I will be saying the volume of the trough. So just want to make sure of my spelling will be, because this, you can see that this is half of a semicircle. Okay, not a semicircle, but half of a if this was a what you call it, this is now a cylinder. And now since we are now dealing with half of that, right, half of that, so it's going to be definitely whatever the formula is for the volume of a cylinder, which V equals pi r square h. The trough, since the trough is half of a cylinder, you must divide the answer by 2. So simply punch in what is my radius. So you're going to go ahead and say, okay, wait a minute, the volume of that trough is pi times 20 squared, that's the radius, times 120, that's being the height or the length. Okay, right. So nothing to be afraid of. You just take your calculator, you multiply and say 20 squared, that's 400. 400 times 120, okay, it's 24,000 or 48,000. 48,000 times pi. So this answer should have been 40. Of course, there's a little problem. We are still supposed to divide our answer by 2. So the answer here will be 24,000 pi. Of course, if it's, you can leave your answer as 24,000 pi, divide by 2 times pi, okay. You can leave your answer as 24,000 pi, or you can go ahead and write 75,400 if you were to give to 3 significant figures. Okay, all right. So this particular case, you can also say or 75,400. Okay, that will be obviously volume. All right, so I'm just going to go ahead and put this answer over here, and I'm going to leave it as 24,000 pi. Okay, it's an exact answer anyway. All right, question 33, the second last question. In a class, data is collected about whether each learner is right-handed or left-handed. Now, I've seen some learners have been struggling with this, okay? But this is a very straightforward question, so to speak. So first, let us find out, key question, how many learners are there altogether in the class? So here we have, let's say, the total number of boys. So let's see how many learners are there in the class. So you have got, the boys will be 3 plus 13, okay? And how many girls are there? So girls are 4 plus 16. So the total number of learners is 36. So there are 36 people in this class. So to find the probability that the learner is a left-handed boy, of which there are 3, so the answer will be 3 over 36, okay? Which you can go ahead and simplify as 1 over 12 or any other way that you want to give it. But that's it. Even if you were to write 3 over 36, that will also be the same. Okay. The mess m grams of 200 chocolates is recorded and the results are shown in the table. Now, the problem that you must understand why they are saying you are supposed to find an estimate of the mean. You can't calculate the mean. Let's look at this class interval here where 30 chocolates have a mass of 15, greater than 15 and between 15 and 25, let's suppose. So there will be some of those 30 will have 16 grams, others will have 17 grams, others will have 18 grams, and so on. There will be 25 grams, but we don't know each individual one. We just put them in classes. So we said between 15 and 25, they are 30. Between 25 and 27, they are 120, and so on. Okay? So if you were to add up this frequency, it will give you 200, the number of chocolate. So how do we find the mean? So if I was to give you values and I say calculate the values, you should not have a problem finding the values. You just add and you divide, by the number of values. So for example, if I was to give you, maybe I should introduce a clean page over here. Let's say we insert a page. Okay, let's say we append a page maybe. So if I was to say, I give you values like 6, 7, 8, and let's say 9, and even 5 for that matter. Okay, and I ask you find the mean of this. Right, so the mean, you will be simply saying, okay, the sum of these, 6 plus 7 plus 8 plus 9 plus 5, okay? And you divide that by what? Divide it by 5, okay, by the number of values. That will give you more or less what is the mean there, okay? Right, so in this particular case, it will be 6 plus 7 plus 8 plus 9 plus 5, okay, divide by 5. We'll say, okay, the mean is more or less about 7, okay? So the mean is more or less about 7. But now if I have to go back to my question, we can't calculate the mean between 15 and 25 because we don't have 16, 17, 18 or stuff like that, okay? So we are going to bring in mid values, mid interval values. So mid value. So what we're going to do, how do you find the mid value? So it's very easy. I wrote it down over here. So you take each class interval. You say, okay, take the beginning value, 15, take the ending value, add them, and divide by 2. That will give you the mid for that table. More or less what is the average between that 15 and 25. Then you do the same thing, the mid between 25 and 27. What is the average there, dividing by 2? And all those mid intervals, once you have them, you will now multiply them by the frequency. So I've done it. So I take 15 plus 25, okay, and I divide by 2. Because very careful, some calculators you must put brackets here, okay. Some calculators you have to do that, otherwise you're not going to get that answer, okay. So what these 20 and 26 and 28 and 32, what these are representing are the middle values there. They are mid values of things that are between, say, between 29 and 35, the mid is 32. So that's the mid value that we are referring to. What do I do then with those mid values? So you take those mid values and you multiply by the frequency. So you like, here the mid was 20. So if I was to, that's why you see some learners or some people, they put mid value over here. They calculate the mid value, add them, divide, and they say, okay, this is 20, and here the mid value was 26, okay? From here the mid value, adding these two, divide by 2 is 28, okay? And here the mid value, 29 plus 35, divide by 2 is 32. So now that they have that, so now you take the mid value, you multiply by the frequency. Add 20 times 30 plus 26 plus 120 plus 28 plus 26 plus 32 plus 24. And you divide it by the number of chocolates. In this particular case, you divide it by 200. And that's what we did over there. So the 30 there is the frequency. Can you see that? That's the frequency. 120 is the frequency. 26 is the frequency. 24 is the frequency. This 20 over here, that's the mid value. That's the mid value, that's the mid value, that's the mid value. Multiplying, adding the sum. Now you must be very careful once you obviously do this multiplication, that you don't end up, making a mistake with your calculator, because it's very easy for students to get this wrong. So if, depending on the type of calculator you're using, first find that numerator, I would say, then write over 200. You're halfway there already with your marks, and then you just go ahead and simplify it, and you write it as a decimal. Please don't need to round this because it's an exact answer. So I will just go ahead and write 26.08. So the mean is about 26 gram, okay, of these 200 chocolates. Right. So I guess that is the end of that particular uh, paper, and I guess that you have learned quite a bit. Stand by for paper 2 that I'm going to post and also explain nicely in detail. You have a lot of blank pages in the paper where you can do your rough work. But I'll be looking at paper 2 that was written, and you can have that so that you can be ready. Remember, I will soon be advertising the booklet I was talking about in terms of its availability to help you to have an exam booklet that can actually guide you. All right, so subscribe to the channel, and also always like and share. The video is going to be public, but soon these videos will be private, and you will only have to access them if you are a member of the channel.